727 aircraft power is provided by three Pratt & Whitney JT8D-15 or -15A engines. These low bypass turbofan engines provide 15,500 pounds at normal takeoff thrust or 14,000 pounds at alternate takeoff thrust. The JT8D is comprised of two independently rotating compressor and turbine assemblies, N1 and N2. This type of engine is referred to as dual-spooled. The N1 low-pressure compressor contains 6 stages, and the N2 high-pressure compressor contains 7 stages. The first 2 stages of N1 compression are called fan stages. Fan stage bypass air is used to increase thrust, cool the engine, and aid in exhaust noise suppression. Bleed air is ducted from the second stage, 6th stage, 8th stage, and 13th stage to operate various aircraft systems. An accessory gearbox, which is mechanically driven by the N2 compressor, drives the CSD generator unit, engine oil pump, fuel module, and a hydraulic pump on the number 1 and number 2 engines. The pneumatic starter system uses air pressure to provide the rotation required for engine starting. A starter valve controls air pressure to the pneumatic starter. During engine start, the pneumatic starter turns the accessory drive, which rotates the N2 compressor. A pressure sensor monitors the pneumatic pressure downstream of the starter valve. The ignition system initiates the combustion of the fuel-air mixture within the engine. Each engine's ignition system contains a single and dual igniter circuit. The single igniter circuit is a continuous, low-energy, 115-volt AC circuit. The dual igniter circuit is a time-limited, high-energy, 28-volt DC circuit. The engine fuel system provides pressurized fuel for engine operation. Fuel is delivered from the tanks to a fuel module through boost pumps and an engine fuel shutoff valve. The fuel module consists of a 2-stage engine-driven fuel pump, fuel heater, fuel filter, fuel control unit, and a fuel flow transmitter. The first stage of the engine-driven pump consists of a centrifugal impeller-type pump. This pump provides suction feed from the fuel tank if boost pump pressure is not available. The fuel heater uses 13th stage bleed air to prevent ice buildup in the fuel system. The fuel heater may be used on the ground or in flight. A fuel heat valve controls the bleed air flow which heats the fuel. The fuel filter collects fuel contaminants. Should the filter become clogged, fuel bypasses the filter. 2 differential pressure sensors monitor pressure difference across the filter. The second stage of the engine-driven pump consists of a positive displacement gear-type pump. This pump provides high pressure output. Should the first stage of the engine-driven pump fail, a fuel bypass valve allows the boost pumps to deliver fuel directly to the second stage pump without passing through the fuel heater and fuel filter. A fuel control unit meters high-pressure fuel to the engine. From the fuel control unit, fuel is measured by a fuel flow transmitter, utilized by a fuel oil heat exchanger, and then routed to the burner section of the engine. The engine oil system provides lubrication and cooling for the engine bearings and accessory drive. Each engine is equipped with an oil storage tank. The tank holds approximately 5 gallons. Engine oil system pressure is provided by a gear-type oil pump. An oil filter collects system contaminants. Should the filter become clogged, oil bypasses the filter. Engine oil is cooled by metered fuel passing through the fuel oil cooler. Oil pressure sensors monitor differential pressure across the oil filter and system pressure downstream of the fuel oil cooler. An oil temperature sensor monitors oil temperature downstream of the fuel oil cooler. The thrust reversers are used only on the ground to deflect engine exhaust forward. The reversers are mechanically operated and pneumatically activated. The clamshell doors block engine exhaust and fan air, and the cascade vanes redirect the engine's exhaust flow forward. The power plant controls and indicators for the captain and first officer are located on the overhead panel. Glare shield, center instrument panel, and the pedestal. The power plant controls and indicators for the second officer are located on the lower panel. Engine instrumentation is arranged for quick scan observation. This arrangement provides approximate 9 o'clock instrument positions for takeoff settings. The engine pressure ratio, or EPR indicator, is AC powered and displays the respective engine's power output. EPR compares the engine inlet and exhaust pressures and displays the difference as a ratio. The EPR set knob sets the reference EPR in the window and the pointer bug on the perimeter of the indicator. The N1 and N2 tachometers provide their own power and indicate percent of rotor RPM. The tachometers also provide secondary thrust setting instrumentation. The exhaust gas temperature, or EGT indicator, provides its own power and monitors the temperature of the exhaust gas. The fuel flow indicators are AC powered and display engine fuel consumption in pounds per hour. The oil quantity indicators display the usable amount of oil in each tank. The minimum dispatch quantity from a maintenance base is 3 gallons and from a non-maintenance base, 2 gallons. The oil quantity indicator test button simulates an empty tank. When pressed, all 3 indicators drive downscale. The oil temperature and pressure indicators display oil temperature and pressure downstream of the fuel oil cooler. The fuel temperature indicator displays the fuel temperature in the number 1 tank.